Okay. Uh, you already learn that how we can measure the pressure of a fluid at a certain depth. If depth is h, then pressure equal to h rho g, right? That we learn. Then we learn at a certain uh, closed flow condition how we can measure the flow, like internal flow through a pipe, and you like to measure the pressure between 2 points, you can add a manometer, right? Or you can use the mechanical pressure gauge and figure out the pressure difference between 2 points. In that case, you need to install two mechanical pressure gauge in two locations, right? Uh, and also we learn how we can figure out the pressure difference between 2 points in a pipe or in between two separate tank by using manometer, right? If you have two tank at a certain distance, say 2 feet or 3 feet, so you need to add two pressure gauge, mechanical pressure gauge to figure out the difference, right? But if you install a manometer, then you need to observe only one location, not the two location. You need to check that how pressure difference between two tank is changing with respect to time. That you can monitor real time by watching your manometer. But in nowadays, your manometer reading you can sense by a sensor, and you can monitor your pressure in a LCD screen or from your laptop by some software, right? But basic principle is same. It work with the manometric principle. Okay, that must be learned. Now, you need to know what is the use of fluid pressure. Where is the application of real world? Why you are studying fluid mechanics? So, if we go through this chapter, the hydrostatic force, then you learn little bit the what is hydrostatic force and what is how it is coming, uh, or how it is work in a object or in a structure. Okay. For example, uh, you like to design a dam, water dam in a canal or in a river. You need to figure out uh, how much it will be stronger, what material you will use, what will be depth of the uh, you know uh, width of the dam at the bottom of your river or canal. For example, if you have a dam like that in a, say, this is top surface, and when you fill up water, then will it come, this side is say water level. This is the water level. So in that case, you need to figure out that how much will be the pressure at the bottom. And that's why they make bottom wider to make sure it is not break. This is one thing. Other thing, you have a dam all the way around. Now, what will be happen if water height in one side is going up in rainy season? Your dam will be overflow or it will break down, right? So, for example, you are designing for your dam for this much water height, but due to natural reason, water height is increasing. In that case, how you can control? In that case, what you can do? You can cut your dam and you can put a gate right over here. Okay, you cut the opening, keep it opening. If you keep it opening, then water will flow immediately through the gate. But instead, you can use a vertical plate to install top to bottom to control it, right? The civil engineer they do, also mechanical engineer they work with this one. And you might see in your eye if you go to in the Mirpur Beribad, you will see. And you attach this one with some screw over here, sometime knob. You rotating this knob, and you are able to open this gate, or you can lower down. Okay, that this way you can control the water flow, or also you can maintain your dam, okay, or the canal. So you need to figure out that what will be the force if water level coming this much, but you are not opening your dam over here, sluice gate is closed. So in that case, how much will be force in the structure? Okay. And if you figure out, then you can design that plate. What will be thickness and what will be the material? Okay. And how we can support, because pressure will work everywhere perpendicular to the surface of this plate, right? So you need to figure out that how we can keep support, how much will be force there. So to figure out that, you need to know some rules that pressure working in the plate. So what will be the resultant force? So resultant force, you can figure out easily that F equal to P into A, right? Area, pressure into area, because P equal to F by A. Now, all the pressure where it is working, that you need to figure out. For example, you have a glass of water full. So all the force right over here is working, right, perpendicular to the surface. This one working perpendicular to the surface, right? Okay. Now, this glass of water, if you put on a paper sheet, say two of your friend holding a paper sheet. This is a paper, and someone holding over here, make it straight, someone holding over here, and put this one in the uh, paper, top of this paper. Then what will happen? The pressure force, that means weight of the liquid, will work perpendicular to the surface, right? So it is working directly downward. Now, this way you can support it. Now, a full of uh, water in the glass, how we can support by a single point? How we can support it? That means if you put your finger, you have to support with the finger. How we can do it? You need to make sure that overall CG, including weight of the glass and the pressure, is working through the same point. And if you put your finger at same location, then you can support this glass, right? Now, if you have a dam, if you think, in that case, say this is bottom of the, this side has a canal or river, this is the bottom of the river, and other side is maintaining dry condition. Okay. Or I give you example that you make a, use a rectangular sluice gate using a plate. Now, this is the water level. How much the pressure right over here? What is the depth from the top surface? Then how much the pressure over here? What is the depth from the surface, right? Pretty surface. Similarly, right over here, pressure will be high. So what I'm saying that now which pressure you will count to figure out the force? you know force equal to P into A, right? But if you consider the bottom pressure, it will be force will be extremely high. Again, if you choose from the top, pressure is low. So which one you will take? So you need to know, derive some equation that how it is working. For example, right over here, water pressure will work perpendicular to the inclined surface, and this way, right? And also it is depend how the surface is inclined. If I say this angle is alpha or theta, the pressure also will depend on the theta. And pressure will not depend along the inclined length, right? It will depend if I take the several some point right over here. Over here, pressure will be, if say for example, this is free surface. That means this much height of the water. Then this height, depending on this height, pressure of this point will vary. Similarly, pressure right over here will vary how much it is depth over here, right? So pressure is not the same everywhere. Now, how then you figure out the force? You have one option that you can uh, take the average, right? This is option. You can take the average and multiply. And that will not be appropriate, okay, if you take the average. Other thing, what the resultant force is working, because in every point force is working. So what will be the resultant? So I am thinking that resultant force in this inclined surface working right over here. How much the inclined distance of this resultant force from the top surface? Or if you think with the vertical distance, then how much will be this distance? That we need to figure out. Okay. So this is the purpose of this chapter. Mainly is this chapter, whatever you learn in this chapter, you are able to apply the rules or equation to design a structure that will be submerged in the fluid partially, or it might floating in the fluid. For example, you design a ship, you design a boat, then you design a sluice gate. Or if you like to something underwater, then you need to know how we can keep it, how much will be force there. Okay, that is the introduction of this lecture. So now of this chapter. Now you need to know some terminology, right? If you like to buy computer, you need to know what is the CPU, what is the memory. That's we'd like to know. Okay. So you need to know what is the total pressure and center of pressure. Total pressure actually mean pressure force in case of hydrostatic structure. Okay. It's a when a static mass of fluid comes contact with a surface, either it might be a plane or curve, the force exerted by the fluid on the surface. This force is known as total pressure. This an act in a direction normal to the surface. Whatever the surface, you need to make sure that pressure always works perpendicular to the surface. For example, if you put a steel ball underwater, then how pressure is work at the top surface right over here, right? The perpendicular to the surface. So what about right over here? It will be also perpendicular to the surface. Every point it is what perpendicular to the surface. the point of application of total pressure. That means if you think that the resultant pressure working through a certain point on the surface, that point is called center of pressure. Point of application of total pressure on the surface is known as center of pressure. It is needed to find the magnitude of total pressure and location of the pressure center to design hydraulic structure. So we need to know what is the magnitude of total pressure or total pressure force, and also what is the location of the resultant force, which is called center of pressure. So we need to know center of pressure and also total pressure. For example, right over here is showing that a curved surface right over here, right? It might be a portion of a bucket or special container or like that, okay? So you fill up this container with a fluid. Then right over here, fluid will perpendicular to the surface, it will apply pressure. And who will balance this pressure? Obviously, the wall of the container has to be strong enough to carry that pressure. For example, you use plastic bucket. So in that bucket, all the pressure of the fluid working perpendicular to the surface and is reacting by wall of the bucket, plastic bucket. But if you make extremely thinner, then what will happen? Gradually you fill up, say initially remain like that, straight, but wall of the bucket is extremely thin. So gradually you fill up the liquid, then you see gradually it will go like this position, because it don't have that much resistance at the wall to support the pressure. So right over here in the right side figure, it's showing a curved surface pressure force from the fluid pressure is working right over here. All the location, not only here, and all the location, the wall is reacting to the opposite direction. Right now, all these force I can consider that resultant of this force working through a certain point right over here. If you mathematically able to figure out that location, then you just need to support this point heavily. Then say instead of bucket, you have a plate like that, and this plate has certain length, curved plate in underwater, not the bucket. Okay. So in that case, if you know this location, your water is also right over here, right? Everywhere is pressure. So if you know this location, then you can support right over here, or you can support right over here and right over here, 2 points. If you support this 2 point, but your resultant force working right over here, right? Working over here. Now you can figure out what will be the, if I make support these 2 point A and B, then what will be the force at point A and B by formula of the beam. So working pressure force right over here. Your point A is right over, so force working upward, and one is working over here. So you can figure out the reaction force R1 and R2 or RA and RB. Okay. So this way, if you figure out the pressure force and the center of pressure, then you can do the next step. Okay. So let's see how we can derive how we can figure out the total force, and also how we can figure out the location of center of pressure. And did you see the slide over here? Inclined surface. Hello. I need your response. You can see, right? Okay. You see right over here, it is a incline. You see it is a inclined surface of a dam. Or if I draw it, so this side is come like that. Okay. Now you have, this is the length or road, and this is the bottom, is the, this side has the water, right? So if you opening right over here, you can put a gate right over here to control the water flow from left side to this side, right? That if you have one option. And this surface is inclined, right? This surface is inclined. You have other option that right over here, you just put a plate with certain thickness along the surface right over here. So if you put a plate right over here through the opening, and you can move this one and we can close it down, right? You can do it instead of putting right over here. This is option. So in the figure is showing that a inclined surface, that inclined surface right over here is a metal or a object or plate right over here. This must at the tip. And this side, water height or height of the fluid right over here. So depth of the fluid in this point will be distance from here to here, right? And we are thinking that this inclined surface of a dam, we make angle theta with the horizontal line, this horizontal line. Now, this surface, if I make a view look from this side, if I look from this side, perpendicular this side, I'll get this surface. And it is arbitrary, not a definite shape. But obviously, in real world, it has a definite shape. Now, you look in the figure along inclined surface. Along inclined surface, I am thinking this is y-axis. So my y-axis along this direction. If I say from along this direction is y, that's parallel to the inclined surface. Then which way is the x-axis? X-axis is the along length of the this dam over here, perpendicular to my screen. So what I'm saying, if you let me draw it again over here, says a dam. I need to just show what is the x-axis, what is the y-axis. So along this direction, inclined surface is y. Say you are standing right over here. So if you coming down toward the water, bottom direction, then that is y. And instead, you just walking along this direction, then this is x. Okay. So that means this angle is perpendicular. Along length is x, and you going down toward the water, that is the y. Now this surface, we need to figure out the how much the pressure is there. So you see, this is angle is theta, inclined surface. So we don't know the what is the area of this one, okay, but we can figure out. So this depth right over here is not given, right over here is not given. But what we are thinking, I will take a small area. This one we can divide in a small segment of area. And we are taking the small segment dA, right? This one right over here, dA. And this dA at the depth h from the top surface. This depth h, the top surface. And along the inclined direction, the distance is y and this thickness is dy. So this write this look point. What will be the relationship between y and h? Easily you can figure out, right? If you apply sine theta equal to, if you make the triangle, this is your h and this is your y. So sine theta equal to h by y. You can easily get over here. Okay, now obviously this structure has a center of gravity, right? And it might be anywhere. Right in the figure is showing it is the top, or it might be right over. We don't know, but just is showing on location. And this center of pressure working right over here. So through this center of pressure, what is the height from the top? We are thinking this height is h bar. And along the inclined direction, this length is y bar. So if you apply again sine theta, you will get h bar divided by y bar. I just put underscore over here. Now, where is the pressure center? We don't know. Pressure center might be what? It remain bottom of CG, or CG remain bottom of center of pressure. It's showing in the figure, this is center of pressure. And I'm showing CG at the top, but it might be right over here, right? We might think, but actually the center of pressure always work at the bottom of CG. And mathematically we can prove it, okay? Now, in the next slide, we'll see how we can derive this. So, what is the area of this strip, this small area? If you know the area, this at this height, we can figure out the pressure. How? Pressure P equal to depth is H rho G, right? Right over here. But still is not accurate, because even it's very small, right over here and the bottom, there is a some pressure difference. This is the vertical height, right? But theoretically, we are thinking this dy thickness is very small, and pressure difference between this point is very negligible. Okay, so in this area, we are thinking pressure is H. I'm sorry, PP, and P equal to H to G because depth is H. Now, what is the area of this segment? We can say this area is dA. So force working in that small area, if I think this is a dF, then dF equal to P this pressure into area. Area is dA, right? Then if you do the integration, then we can figure out the force working in the whole plate. Okay, that is the approach we will follow. So if we follow that approach, right over here, that's showing which is the x-axis, which is the y-axis. That we already discussed it. It's saying that if we assume the plane surface AB, that means this is showing A, the point not A, this is showing point B. This point A, this is point B. That means what is meaning the surface AB is made of infinite number of horizontal strip and is having width dy and area dA. The hydrostatic pressure on the strip is considered constant because width of the strip is very small. And for a strip, depth is H below the free surface. So at a depth H, how much will be pressure right over here? So P equal to gamma H, or this H, again we can apply the sine theta cos theta, because sine theta equal to H by Y. So this H we can substitute by this term. Okay. Now we figure out the how much force working in that small area. The force equal to pressure into area. So dF equal to pressure into area. Now P equal to gamma Y sine theta. That is right over here. Or you can write down rho g y sine theta, because gamma equal to rho g, right? Now if I integrate in the both side, left side you are getting F, area integration, you get this term, gamma y sine theta dA. Now this term, now we see y dA. Y dA, if y is vary, this y, this y decreasing y value, then a width of this area strip dy, we are saying dy, this dy value will increase, because if you think that this right over here, this mass is y from here to here, and this mass is dy, then area will sense, right? That means what I like to say, that y area also depending on value of y. So that's why this in the integration, gamma sine theta, we bring it out of integration, and this one we are saying area integration, y dA. Now, so F equal to gamma sine theta y dA, right? Now, we need to know what is y dA. What is this one, y dA? Again, you are applying the law from your engineering mechanics. Right over here, it's showing integration. Integration of y dA, right? So integration of y dA, what does it mean? Summation of y into area, right? For example, this is my x-axis, this is my y-axis, and I have some area over here. If I make a segment, small segment, I'm saying each area is dA, this is area dA, then I will multiply his CG. What is his CG? Y, right? Because barrel axis is Y. So Y into dA, what will get? Moment of area, right? And you take all of them, then you can say summation of, you can say summation of A1 into Y plus y bar 1. That means summation of area 1 plus y bar ycg of the area 1 plus area 2. That means the small other one. Area 2 into y bar ycg of the area 2. Now we make all of them. Okay. After making the summation, you divide by the area. Then what will get? Anyone? Anyone? Sorry. If you say area I into y bar I, and I vary from 1 to n divided by total area, what will get? Anyone?
So why?
You are getting not y, ycg of the entire body. Okay. Say you have a body, this is x, this is y. Could you hold on 1 second? So this, now this one, it divided several area, 1, 2, 3, 4, 5, 6. And you working is area, you figure out the area and y, then make all the summation divided by the area. Then you will get ycg of the whole area equal to, you will get ycg. So in our problem, we get right hand side integration of area a dy, right? A dy. Sorry, y dy. We are getting integration of y dA. This y dA, if I divide by area, then I will get y bar or ycg. Okay. So that, understand this one. This one here from your engineering mechanics. How we'll figure out, the CG of a body. That body is made of multiple type of body. Say you have a this kind of say structure. You can easily make it, right? Or there is might be a hole over here. Then how will you figure out the CG? You can figure out a triangle, then figure out for the square,
Square
subtract.
and a circle.
Yeah, circle you have to subtract.
Yes.
Then you'll get the location of the YCC. That you learn in the engineering mechanics. So you see right over here in the next slide, this one, right over here we have YDA into A. So this is summation of the area. So if I divide it by area A, that means I think that total area of this plate is A. Then I am getting y bar. Y bar means inclined distance of the CG. This is the y bar right over here, inclined distance. This is CG. So right over here, I need to figure out, this is my formula. From here, I can figure out value of YDA. So YDA, this is my gamma sine theta, right over here, gamma sine theta. So this value of integration is coming y bar into A. That is written over here. Y bar into A. Now, you have a sine theta. Now, sine theta into y bar is equal to h bar, right over this. The h bar is the vertical depth of the CG. Okay. So finally, you are getting the total force in the structure. So how will figure out? You need the value of gamma. Gamma mean rho g. Then depth of the CG, any direction. If you know the angle and y distance, you can figure out the h. Or you can say h equal to y bar sine theta. Then you need to know area of this plate. What is the area? Then you get the pressure, total pressure force or total pressure working on the structure. Now, you need to figure out that what is the location of this center of pressure, the YP, where it is working. So we need to figure out the value of YP. So let's see how we can figure out value of YP. This slide is the same thing. I just explained it again over here. So it's a total hydrostatic pressure force on any submerged plane surface is equal to the product of the surface area and pressure working at the centroid of the plane surface. You see what is the gamma is. Gamma is actually is the pressure. And that pressure working at the center of gravity or centroid of the plane surface. Okay, if you say you are putting a this rectangular plate, so you obviously know the location CG will be right over here, right? Then you know the angle, then you can figure out the uh, depth of the CG, then figure out the pressure, then multiply by the area. And it might be any kind. For example, you might have a trapezoidal plate, or you might have a rectangular plate. You might have a hexagonal plate. Any type plate you might need to work. Okay. So just you need to figure out the CG, vertical depth of the CG, then figure out the pressure at the CG, multiply the area, you get the force. Now, we need to figure out where is the center of pressure working. If you know that point, you figure out the what type of support you will use. Okay. Now, how will figure out that one? I already show you the x-axis, that x-axis working perpendicular this paper along length of the dam or river, right? So you see this one, this plate is not rotating. It remains static condition, right? There is no rotation. So if you take a moment right over here with all the force, then it has to be 0. So what I'm saying, force working in this small area, how much? DF, right? That force working in the small area dA equal to dF. What will be the moment of this force respect to this point? You are taking along inclined surface. So right over here, force working through this small strip dF. So distance is y. So I can say this dF into y. dF into y will be the moment of the force from this point, right? Because this dF working at a distance y. Now this moment is working only on the small surface. So how you can figure out the total force, moment of the total force? What need to do? Similarly, you have other small segment. If you think that all the plate have a small segment, area is dy, uh, width is dy, and force working each segment is df. You just make the summation of the all force. That means you have to do the integration of area of the force, df into y. So that will be total moment of the all force working right over here. Okay. Now total force, amount of force, how much force work, we already figure out in a previous slide, that F equal to gamma H bar into area, right? That we already figure out right over here, that F equal to gamma sine theta, because sine theta into y bar equal to H. Instead of H, they write down y bar sine theta, and area and gamma is over here. This is gamma, this is area, y bar sine theta equal to H. Okay, so this moment, you take summation of the moment working in every segment of the small strip. Now, what is the overall force working? Resultant force. Resultant force working through the center of pressure, through this location. Resultant of all these small segment area, this is the force F. So what is the distance of this from x-axis origin? Distance is yp. So moment of this resultant force equal to yp into distance, and I'm sorry, yp is the distance, so distance into force. That means f into yp. That in the left side. So this one and this one, it has to be same or different. Anyone? Both has to be same. If it's not coming same, then we cannot figure out the total force. So total force F, how we figure out? We first think that all the plate area is divided into very small segment. Then we figure out the pressure force in small area, then we did the integration. Now, instead of summation of force, right now we are taking summation of moment, force into distance. So we know that overall force is F, resultant of the all mole force working in each surface, perpendicular to the surface from top to bottom. So resultant of this all force is F. So, and where it is working? Through the center of pressure, and that is we denoted by yp. So moment will be yp into f. Now this yp into f, we are getting respect to amount of resultant force working in the plate. Now if we think this force, amount of small force right over here df, over here df, and also over here df. That means all the small arrow is working in the small area, force is df. So how much will be moment for right over here? df into this distance, right? For this force, df into distance. For this force right over here, df into distance. If distance is y, then we can say df into y. And then we take the integration of area. So that's why we are saying this term and this term is equal. So from here, we can say yp equal to right hand term divided by f. Now, and value of df, we already figure out from the previous slide. If you look in the previous slide, that df equal to gamma y sine theta dA. So this dF will put it there. Okay. So as a dF equal to gamma y sine theta dA. And what is the value of f? Right over here dF. In the bottom we have f. So how we can get the value of f? Right over here. F equal to, if you take out the h bar, then gamma y bar sine theta into a. That we put f equal to gamma sine theta a y bar. So if you, what you getting? You see this term is coming at the bottom and this term at the top. So you see gamma is remain both sides. So gamma will be out from top to bottom. Sine theta will be out, right? So at the top, there is a one y, this y into this y. So it's coming y square. Then area integration dA. You get this one at the top, y square dA. And the bottom, what will remain? A y bar. So finally getting a y square dA divided by a y bar. Right over here. Okay. Now, what is the y square dA? Anyone? What is the moment of inertia? Anyone? Say this is x-axis, this is y-axis. If you say this is, I have a small circle over here. I'm saying this area is A instead of D. I'm showing area A. So if CG is right over here, and if you know this CG is Y, so what will be the IX? What is the meaning of IXX and IYY? Anyone? No?
So
Anyone?
moment of inertia with respect to x-axis.
Yeah, moment of inertia. What is the unit of moment of inertia? Meter to the power 4 or inch to the power 4, right? How actually it is coming? Inch to the power 4 or meter to the power 4. Moment of inertia is, you have to take double moment. At first, area into y. Y means CG. So you make area moment. What is the force? Force moment. If I say moment of force equal to force into distance, right? That we figure out. Now, moment of area, A, moment of area will be area into distance. So instead of distance, what is distance? We are saying CG, area into distance. So what is moment of area? Inertia is the moment of area. Moment of area, that means second moment of area. So I equal to MA, first moment of area, again you take second time, that again you multiply by y bar. So ultimately what you getting? MA area into y square, right? MA equal to AY. So ultimately getting you area into y square. So area into y square, unit of area is meter square, again y is y square. So that's why unit of moment of inertia coming meter to the power 4 or inch to the power 4. So what is that one? Area, moment of area, second moment of area. That means you take first time moment of area, y into area. Second time you take again by distance, So it's coming y square into a, right? This is coming. This is called, and this equal to, you will get ix. Now, instead of area, if you make a segment with small area dA, then this will be your moment of inertia along x-axis. And this formula I already give you in your first or second lecture, I think. So if you look in your engineering mechanics books, you will say Ix equal to y square dA integration, and Iy equal to x square into integration dA. This is area integration. If you look, you can see your engineering mechanics class note, you might have it. Okay. So you see this term, I can say this is Ix. Ix mean right over here, the x-axis is going, this is my top surface, along this direction is y, along inclined surface, this is my x. So along this x-axis, I am getting inertia, y square into dA. Right over here, my area. What is the distance from area to here? Is y. This area is dA, then first moment will be y into dA. Second moment, y dA into y. So that means coming y square dA. So this is my Ix. Ix giving the inertia respect to which axis? Respect to x-axis. But object is where? Right over here. Okay. What is the inertia of a rectangle? If I say this is height h and base of the rectangle is b. Anyone? What is inertia? If I think this is x-axis and vertical y-axis, then what will be the Ixx? Anyone? You forgot? 1 by 12 b h cube, right? This is Ixx. But what will be Iyy? In that case, 1 by 12, b will be my h. So h into b cube, right? This is inertia. This inertia is given respect to which point? Anyone? This inertia you are getting respect to CG of the structure, right over here. CG of the structure. Okay. But if figure out CG of the structure, then this formula you can directly use. But my axis, y axis right over here, x axis right over here. Okay. This distance, the CG to x axis is this much, and this distance I know. Say distance is d. If this distance is d and area of this rectangular is a, then how we can figure out the inertia of this area with respect to x-axis? Which formula you will use? Anyone? No? Tuhin? Majidul Fahim? Anyone? Do you heard the name parallel axis theorem? What is parallel axis theorem? Like this one, uh, respect to CG, this is rectangular area. Respect to CG, your have two inertia. One is x-axis, I-x-x, or other one will be I-y-y. So both are given respect to this CG. That you can figure out by this formula, right? So
Sir,
this
IXX plus A into D square.
AD square, good. Who is speaking?
Sir, 116. Dhruv.
116 what's your name?
Sir, Dhrubodhar.
Dhrubodhar. Okay, good. This is parallel axis theorem. That means if you figure out the IXX, then your IXX will be equal to ICG. That means moment of inertia respect to CG plus area of the object into, we are like to figure out along x-axis, from x-axis distance how much? D. So into D square. And this ICG should be respect to x, not respect to y. Okay. Similarly, if I like to figure out y, then by parallel axis theorem, then what will be my formula? That means along this axis. So along this axis, I need this distance. If this distance is, I am saying dy, the subscript dy, then in that case, right here will be ICG, but respect to y. So we can use a bar. I can say ICG bar. That means respect to CG of the object. That will be right over here, the bottom one, 1 by 12. If I say this is B and this is H, in that case, bottom one will be ICG or IYY plus area into D square. So in that case, distance will be my dy, not this one, because distance you are measuring from y-axis, this one. Okay. Actually, this one I am not supposed to tell you. I just supposed to give you the write down the equation because you already learn it. But I try to explain you by your to refresh your memory and make sure that you understand clearly. Now, so bottom top part I am getting IXX. So object is right over here. His is right over here. So how I'm getting IXX right over here. So this IXX, IX, inertia respect to x-axis equal to inertia respect to CG of the object, right? So CG of the I expressed by I naught. That means inertia respect to CG right over object plus area into D square, distance. What is my distance right over here? CG distance is y bar. So I can say area into y bar whole square. That we put over here. This is IXX, this is equal to IXS, and we know IXX equal to again this one. Now this IXX we put on the top. So we get YP equal to I naught plus A y bar square and the bottom A y bar. Now you just simplify. So you are getting this value plus y bar. Now you look carefully. What is y bar? Inclined distance of the location of CG, right? This y bar. Inclined distance, location of CG. Now you see I naught inertia respect to CG of the object. In the bottom, area of the object into horizontal distance. So if two value you see is always higher than this value YP, because this value will be how much? So from here, I cannot say that YP is always greater than Y bar, because if I think this is 0, then what are we getting? Yp equal to y bar, but this value never be 0, right? If I naught is 0, when this value can be 0? If I naught is 0, then this value come 0. Then what will get? We'll get Yp equal to y bar. That means y bar, Cg and the center of pressure, both are working at the same point. But it never be true, because this value always positive value, not the negative value. It's a constant. So Yp, from here, this equation, we can say that Yp always greater than Ycg. That means center of pressure always work below the center of gravity. So right over here, it's saying I naught is the moment of inertia of the plane respect to its own centroid. A is the area of the plane surface, and y is the distance between the centroid and the x-axis. Okay. So far, any question? Any question? No? So right over here, so far we found two equations. Number one equation, we found the force. What will be the force on the object? This is the formula. Either you can use this one or you can this one. Same thing. You just need to apply the trigonometry of sine theta cos theta over here. And what is the location of center of pressure? Center of pressure equal to moment of inertia of the object respect to Cg by divided by area into location of y bar plus y bar. So you see this formula, location of the center of pressure, and this is the amount of force. So any structure is submerged in a fluid. If you know the density of the fluid, if you density mean you need to know rho, or you need to know gamma equal to rho g. Then you need to know what is the area of the object A. Then need to know what is the area, inertia of that object respect to its Cg. And you need to know what is the vertical distance or what is inclined distance. This is inclined distance y. Or you need to know the vertical distance A is of the Cg of the object. And if you know this angle, then you apply the trigonometry sine theta cos theta. You can figure out location of center of pressure, and also you can figure out the force. Okay. Sometimes, for example, a rectangular object remain in the plate right over here. So this plate, instead of square, it is rectangular. So how we'll figure out the Yp, how we'll figure out the force? At first, you need to figure out the Cg of this object. One thing you need to remember, Cg of the object from the top surface distance, you have to take the vertical or inclined distance from top surface of the water to the Cg. So if for this object, if you know the area of the object, obviously this is a triangle, right? If you know A, B, C, 3 length, you can figure out the area. Also, you can figure out the location of this Cg. From here, it will be 1/3 of height of the triangle, right? You can figure out the Cg. You have the area, then if you know the vertical distance, then you can figure out the force. We have some problem over here, then we easily be able to figure out. Now, you see right over here, just given some, like a sample calculation data sheet. If you have a rectangular object, then how much will be your xcg, ycg respect to cg of the object. So area will be b into h, right? So if this is h and this is b, along this direction we are thinking x, vertical direction is y. So in that case, x bar equal to half b, the right over here, right? If you think at the corner, x bar will be half b, then y bar equal to half h. It's showing right over here that this is CG. What will be CG location? Y, and this will be the x. And what will be the inertia? I naught respect to this point. I 1 by 12 b h cube. If it is a triangular, half b into h. X bar, y bar is h by 3. I naught is given. Then for circle, your location will be xy, will be half of diameter, that means radius, and I naught equal to this much. And if a trapezoidal area, then area equal to length, average length, a plus b divided by 2 multiplied by h. This is the formula to figure out the y bar. Y bar mean this vertical height of CG, this height. And this is the inertia respect to CG of the object. Similarly, if you have a semicircle, you might have a semi-ellipse, then how we can figure out the area, how we can figure out the CG, how we can figure out the moment of inertia. That means you don't have to calculate like you did in the engineering mechanics, but you are using the knowledge of engineering mechanics, right? So if I give you a problem in the exam, then I have to give you the data. Say, if I give you this parabolic section, if I give you a I might say, here is the parabolic section, A is equal to this mass, B equal to this mass, submerged in a water at angle this much. Then you need to calculate the area by using this area. You need to calculate the CG. Then you need to calculate the I naught. But this formula, I have to normally I give you with the question, okay? But if I just for a rectangular, I might not give you, okay, because it's very simple. You don't need to, as an engineer, you have to memorize the formula for simple things. Say for a circular, you know, the radius YC will be at the center, and I naught will be pi by 64 d to the power 4, right? Any so far, any question? Anyone? Anyone? No question? Okay. Yes, yes, go ahead. Any question?
No, sir.
We can solve this problem. Okay. You see a trapezoidal gate is submerged in water, right? And the depth of the top surface is 5 meters from the water. And this height of the trapezoid from here to here is 3 meters. This length is given. Now you need to figure out the total pressure force F will be how much, and YP, center of pressure on the gate. Now, what is the difference over here? What do you see? How much the angle? Anyone? You see, we derived the formula that surface was inclined, right? And right over here, there was a plate. And if we go back to the formula, let's see which one is theta. They're giving theta this one. If theta becoming 0, then what will happen? Theta becoming 0. So this angle is theta. If theta is gradually decreasing, becoming 0, that means this line gradually become horizontal, right? That means this plate will remain float in the water. Horizontal, it will be horizontal location, right? But if this plate is, if theta say increasing, right now say 45 degree, then it become 50, then it come like that, right? Become 80, then incline, become 90, then straight vertical. Clear? So it's saying a vertical trapezoid. So he already mentioned saying vertical trapezoidal gate. That means right over here, angle will be 90. So we have two formula. One is for pressure, force, F equal to this one, or you can say this one. And we know our formula, H bar equal to Y bar sine theta. But right over here, theta equal to 90. So you get H bar Y bar is the same. So what is the Y bar? Location of CG of the object from the top surface, right? So this is my top, is CG is right over here. If I mark it right over here, then Y bar will be this mass distance. Sometime you might think Y bar equal to this mass from here to here, but this is wrong. Y bar is the distance from the free surface of the water. So we need to figure out that what is the CG of a trapezoidal area. So that means we know this height, 5 meters. Overall depth of the top surface, we already know 5 meters. So if you able to calculate this distance by formula, by location of CG, then this distance at plus 5, that will be location of Y bar. So this is the, and how will figure out the location of center of pressure? Y bar equal to this formula, I naught A Y bar plus Y bar. Okay. Now, right over here, formula is not given. But if you look the previous sheet, trapezoidal area, right over here, you see if smaller length is A, bigger one is B, and height is H, then this will be area. But in our case and this one, what is the difference? Figure given over here, is smaller n at the top, right? But in our case, smaller n at the bottom. That is the difference only. Otherwise, this will be A, this will be B, height is 2 meters given. Easily you can figure out the area. But if you look location of CG, Y bar, where is the Y bar? Given from the, this is Y bar, is given from the horizontal line of bigger S, right? So in our case, formula will be same, and this is the Y naught. That means inertia respect to CG. So in our case, we will get distance from here. Directly, we will get distance from here to here by formula. So 5 plus this distance, you will get the Y bar. So let's see how you can start. You can say depth of the water is 5 meters. At first you write down what is the data given. Then you write down rho of water, density of the water, rho or W or water equal to 1000 kg meter cube. Then you can do two things. Okay. After you getting the question paper, you answer to the question number 3. Then you draw the sketch. Then you write down given what is given. Sometimes we have seen that you are not drawing the figure in the answer sheet. You might just looking in the question paper, and you write down given AC equal to this much, everything is given. Your answer is right, but since you are not following the procedure, then your result mark will be reduced. Okay, but you have two options. You can write down given what data given. The right side you can draw the figure, or at the top of your answer sheet you draw the figure. In the bottom you say what data is given. So in our case, depth of water is given 5 meter, density of water given, and A equal to 1 meter, B equal to 3 meter, and H equal to 2 meter. You write down trapezoidal geometry given, then you write down this one. Why mark with A, B, and H? If you look in the right over here, the smaller end they mark with A, bigger end mark with B. Now, by mistake, if you this one you identify by B, this one by A, using by same formula, then your result will be wrong. So you have to match your dimension with the formula. Then your result will be right. So then you solve the problem. So you know the formula, we need to have area, Y bar, then I naught. These three things you need to figure out. So figure out area. A is by A plus B by 2, 4 meters square. Then you figure out Y bar. Y bar mean YCG by this formula. So in that case, this is CG, this will be YCG. Or so YCG 0.83. Then you calculate the I naught. That means inertia of the object respect to this point by directly by formula. I naught equal to this mass. Now, this is YCG. Let me write down one thing. This YCG, and in the formula we have Y bar, both not the same. What is the Y bar? Y bar is the overall distance of the CG from the top surface. And this YCG is giving you location of center of gravity with respect to the edge of the object, right? From top edge or from the bottom edge. But this y bar, you have to count from the top surface of the water. So in our case, this y bar, right over here, y bar, h bar is the same because angle is 90 degrees. So I write down h bar equal to h depth plus y cg. So 5 meter, then you add YCG value 0.83. So 5.83 is the Y bar, or you can say H bar. Any question so far? Any question? No? Okay. Now, what is our formula for figure out the pressure force? F gamma sine theta AY. Sine theta equal to how much over here? 90. Theta equal to sine theta equal to 1. And H bar or gamma bar is the same. So we already figure out H bar. So hydrostatic force gamma y bar sine theta into A. Then gamma equal to rho g. Y bar H bar same. Then in area. Then you put all the value, you get this is the 229 kilonewton. Center of pressure. This is the formula. Y naught, I naught, that means moment of inertia, respect to CG of the structure, that we got 1.22 meter to the power 4, divided by the area you already got, then Y bar. This Y bar again, we got 5.83 from the top surface of the water. So you put Y bar, then Y bar, you get 5.88. So you see from this problem that this is your top surface and location of center of pressure from here to here is 5 point. This is location of center of pressure is coming 5.88. And what is location of CG, Y bar? 5.83. That means Y bar CG of the structure is locating some right over here. So this is center of gravity of the structure. That means always center of pressure should be bottom of center of gravity. Okay. Anyone? Any question? Hello? No question? Okay. Our class is until 10:30, so we can stop it here. In the next class, you have question?
স্যার একটা কথা ছিল স্যার।
Sure. Yeah.
স্যার আপনি
Quiz.
মানে জি স্যার কুইজের ডেট দিয়েছিলেন 15 তারিখ, কিন্তু
Yeah.
আপনি লিখেছিলেন ওয়েডনেস মানে বুধবারের কথা লিখেছেন, কিন্তু 15 তারিখ তো স্যার বৃহস্পতিবার।
Really?
জি স্যার।
Okay, so whose date you want? Thursday is the 15th and 14th, Thursday 15th, right?
Yes sir, yes.
Okay, so which one you prefer? I already post in the someone asked me question, the sir, you give me in Tuesday, but you change the date. But I'm saying any day you can take. Thursday you have problem? Anyone?
Thursday.
Yes sir, ওই দিন আমাদের ল্যাব
I
আছে,
check the
উইথ ল্যাব আছে থার্সডে।
Okay. So which day then you want?